geobyte.
Another important problem asking like this. Two particles of masses 1 gram and 2 gram move towards each other with a velocity of 10 meter per second and 20 meter per second. This is the m1, this is the m2. Here m1 is 1 gram, m2 is 2 grams. They are moving towards each other, means both are moving in the opposite direction with velocities 10 meter per second and 20 meter per second. V1 and V2 are opposite respectively. The velocity of the center of mass of the system of the two particles. Velocity of the center of mass equal to m1 v1 m1 v1 plus m2 v2 dividing by m1 plus m2. Since v1 and v2 are opposite, I can take minus m1 v1 plus m2 v2 by m1 plus m2 minus m1 1 into 10 plus m2 m2 2 into 20 divided by 1 plus 2. It is minus 10 plus 40 divided by 3. It is 30 by 3 equal to 10 meter per second. That is the velocity of the center of mass. Look at the option B. Option B is absolutely correct. Understood clearly? Yes. Similarly, let us take the another important problem. Okay. Look at the screen. It is asking like this. A ball moving with velocity 2 meter per second collides head on with another stationary ball of double the mass. For that, let us take m1 equal to m and m2 equal to 2m1, that is equal to 2m, and initial velocity of the first ball, initial velocity of the first ball is what u1 equal to 2 meter per second, and the second ball is at stationary condition u2 equal to 0. Okay, if coefficient of restitution is zero point 0.5, coefficient of restitution, let me write it clearly. Coefficient of restitution, let it be small a, zero point 0.5, then their velocities in meter per second after collision. Let v1 be the velocity of the first particle after collision, that v1 is how much, and v2 be the velocity of the second particle after collision, that is how much. Okay, for that, as you know, velocity of the first particle after collision is equal to m1 minus em2 into u1 plus 1 plus coefficient of restitution into m2 u2 divided by m1 plus m2. Let us substitute all values. m1 is m minus e value given 0.5. m2 is 2m multiplied by initial velocity u1. u1 is 2 meter per second plus 1 plus 0.5. m2 is 2m. u2 given 0. Dividing by m1 plus m2 means m plus 2m. It is equal to m minus 0.5 into m minus m, 0, 0 into 2, 0, 0 plus 0 by 3m is equal to 0. That means final velocity of the first particle after colliding is 0. Similarly, velocity of the second particle after collision is m2 minus em1 multiplied by u2 plus 1 plus coefficient of restitution into m1 u1 whole thing divided by m1 plus m2. Let us substitute values. m2 is 2m, minus 0.5 times the m into u2 0 plus 1 plus 0.5 into m1 is m, u1 is 2 dividing by 3m. This first part is becoming 0 because anything multiplied with 0, 0, 1.5, 1.5 into 2m by 3m. M cancel. It is equal to 3 by 3 equal to 1 meter per second. That means velocity after colliding, the first particle is v1, that is 0, and velocity of the second particle after colliding is 1 meter per second. 0, comma 1. Look at the option A. Option A itself is absolutely correct. Understood clearly? Yes. Then let us take the another important problem asking like this. Two particles of masses 5 grams and 3 grams are separated by a distance 40 centimeters. The center of mass of the system of these two particles is. For that, let us take one particle here. That particle is maintaining the mass m1 equal to 5 grams, and other particle, this is the another particle of mass m2 equal to 3 grams. These two are separated by a distance. These two are separated by distance. How much it is given? 40 centimeters. 40 centimeters. Now, this is the particle 1, particle 2. For deciding the what is asking center of mass. For deciding the center of mass, we need to take one of the mass is, one of the particle is reference point. I am taking, right? This is the reference point. Reference point. Then here m1 equal to 5 grams, x1 equal to 0, m2 equal to 3 grams, x2 equal to 40 centimeters. Then center of mass distance equal to m1 x1 plus m2 x2 dividing by m1 plus m. Here m1 is 5 grams multiplied by x1 0 plus m2 3 grams, x2 40 centimeters divided by 5 plus 3. It is 40 into 3. This part is 0. 40 into 3, 120 divided by 8. Right? Here it is 8, 1 times 8, 5. 15, 8, 1, 8, 15. 15 centimeters. 15 centimeters from 5 grams. Look at the options. 15 centimeters from. So here it is correct one, 3, 5, 8, 40 into 3, 120. 15 into 8. Correct only. Right. So the center of mass is at distance of 15 centimeters from the 5 grams particles, lies at a distance of 15 centimeters from 5 gram particles. Option A itself is absolutely correct. Understood clearly? Yes. Then look at the another important problem asking like this. A body falls freely from a height of 100 meters onto the ground and rebounds to a maximum height of 36 meters after collision. It is like this. Let this is the hard horizontal surface, hard horizontal surface. With respect to that hard horizontal surface, the body is there. This is the body is at a height of h equal to 100 meters. Then it is rebounding to a height h equal to 36 meters with okay, coefficient of restitution between the ground and any body is, you are asked to decide what is the coefficient of restitution. E, very simple. As you know, E square into small h equal to capital H. This relation already we have discussed. From this, E square equal to capital H by small h. Capital H is 100, small h is 36. It can be written as 10 square divided by 6 square. So anyhow, E square equal to 10 by 6 whole power, 10 by 6 whole power. Here it is, 8 minute, 8 minute. Here it is reverse, no? 8 minute. It should be reverse. E square into, here E square into capital H. Capital H equals small h. That is correct. Then E square equal to small h by capital H. Small h is 36 divided by 100 can be written as 6 square by 10 square. Then E square equal to 6 by 10 whole square. This square part is cancelled. Finally, E equal to 6 by 10 equal to 0.6. That is the coefficient of restitution. Option C is absolutely correct. Understood clearly? Yes.
Geobyte.